Kia ora. This is a question from the 2009 exam, and it's one where there's quite a lot of text and it looks hard, but it's pretty clear what you have to do, and I think not too difficult at all to get all the way through to the end of the problem. So we're given this really cool looking graph for what's called a cycloid. So that's here, and we're told, what do we got? Oh, the position of a point on the edge of a circle of radius 1 when the circle rolls along the x-axis is given by these parametric equations. Right, so you will have done parametric equations during level 3 calculus, and hopefully you saw that we get lots of really funky graphs when we have parametric equations often, right? So maybe your teachers showed you things that look like this, right? Or, I don't know, all kinds of weird things. Right, these are all parametric equations. Maybe not that last one. Anyway, the one we've got here is given by these two equations. So like a merit level skill for level 3 diff is to be able to find dy by dx. But we don't even have to do that here. What we're given here is the speed at which that point on the edge of the circle is rolling is given by s of t is equal to this. Now, I don't think it's that helpful to have s of t. I'm going to change that to v of t for velocity. And the scalar acceleration of the point is given by this. Right? We don't really need to know what the word scalar is doing in there. We just know that we're doing what feels like a kinematics question. Even if you've forgotten everything you knew about kinematics, the question is guiding you with exactly what to do, right? We're going to first find and simplify an expression for s of t. That's this thing here. Then we're going to differentiate that and get an expression for a of t. So it's not even as hard as doing a second derivative parametric, right? So let's just get into it. We've got x is equal to t plus sine of t. And y is equal to 1 plus cos of t. As usual, I'm going to do my build-up before I put it all back under the square root sign. So dx by dt is equal to 1 plus cos of t, and dy by dt is equal to negative sine of t. Dx by dt squared is equal to this thing here squared. So I could put that in brackets, or I could just get on with it. I've got 1 plus cos squared of t plus 2 cos of t. Right, now it's not a show that question, so that's why I'm being slightly loose with that step in there. Next up, dy by dt squared is going to give me sine squared of t, because negative 1 times negative 1 is 1. Right, so now we are ready to pop it into our expression for the speed, which is going to be the square root of 1 plus cos squared of t plus 2 cos of t plus sine squared of t. And that gives me, using the Pythagoras identity, 2 plus 2 cos of t. And I'm going to pull out that root 2. I'll go slowly on this. If you're watching this and you're about to sit the exam, this is probably feeling really easy. If you're watching this next year and you're just getting into these problems, you'll notice just how much manipulation work we've got to do. So I'm going to pull out that root 2, and we get root 2 times 1 plus cos of t to the power of a half. I'm writing it like that because I know that the next step is going to be to find an expression for a of t. So that first part is done. I'm guessing that was probably worth 1 mark. There wasn't too much hard in that at all. And then the acceleration expression is going to be root 2 times a half 1 plus cos of t to the power of negative a half. And then using the chain rule on this, I need to multiply by negative sine of t. Right, hopefully you're realizing how crucial it is that you can fluently differentiate trig functions. If you can't do that yet, go and get the Delta textbook, or go on Dr. Frost and do heaps of last-minute practice at differentiating trig functions. I promise you'll need them in 10 days' time. Right, negative sine t over root 2, and then here I'm going to write this back in surd notation, and I've got this. Okay, so that's my expression for a of t. I can't simplify that anymore, but what we're being asked to do is to show that a of t is not continuous. So we've got a fraction. We can't have the denominator equal to 0. So it's going to be undefined when root 2 times this is equal to 0, which is the same as 1 when 1 plus cos of t is equal to 0, which is when cos of t is equal to -1. Now, when's that going to happen? Note that in the question, we were told that t was between, so it's shown in the question for between -4 pi and 4 pi. So I'll start off with that, but actually it would be good to show like a general rule for those discontinuities. It's not going to be hard to do. So let's just draw our cosine function. Here it is. Right, when do we get -1? Well, we get -1 at pi. That's 2 pi there. That's 3 pi here. So -1 at -pi and at -3 pi. So it's discontinuous for, and I think it's fine just to say, for odd multiples of pi, e.g. -3 pi, ... -pi, pi, 3 pi. If you want to be more formal about it, you can say for, to get an odd number, remember we go 2n plus 1 pi, where n is an integer. Okay, so I think that's all there is to do in that question. Let's just check. Yep, okay, find an expression for a of t. We've done that, and hence show that a of t is not continuous. All right, that's all for tonight. I will do some more from the 2009 paper tomorrow if people are watching. So let me know if there's anything else that you would like me to go over with the YouTube in the next couple of days.